Hi guys, in this video we will be talking about some particular functions. So if you have to integrate 1 upon x square minus a square, the answer that you will get will be 1 by 2a log modulus of x minus a upon x plus a plus c. If you want to integrate 1 upon a square minus x square, it would turn into half a in the denominator, or 1 upon 2a log of modulus a plus x upon a minus x, and so on and so forth. So we will be talking, I'll be solving each one of them in this video, in other videos. So we will be solving, these are some special cases. Now, I'm going to take the, first of all, the proof of 1 upon x squared plus a squared. So let's integrate 1 upon x squared plus a squared. So the trick out here is that you take x as a times tan theta, which means theta is 1 upon tan inverse x, which means dx will be, if you just integrate, if you just differentiate, so dx is equal to a times secant square theta d theta. So that gives you what is dx. Now just substitute. So your integral I turns into a times secant square theta d theta upon a square tan square theta plus a square. So if you take a square common, so one time your a, this a cancels with a square here, so 1 upon a secant square theta upon tan square theta plus 1. Now taking tan square theta plus 1 as we know that tan square theta plus 1 is equal to secant square theta, or in other words, tan square theta minus secant square theta equals to 1. So this cancels with this. All you are left out with is 1 upon a d theta. Now integrating that, you will get 1 upon a theta plus c. Now what is theta? We've taken x equals to a tan theta. That means theta is tan inverse x, right? So you've taken x as a tan theta. So theta is basically tan inverse x by a. I think I forgot to write that here. X by a. And hence, this is what the integral is, and that's what I mentioned out there. So the special case 1 upon x square plus a square is 1 upon a tan inverse x upon a plus c. Okay, let's see what we have in store now. Let's find the following integrals. Find the following integrals. First one, sine cube x into cos square x dx. So sine square x, what you can do here is, you'll have to think of some substitution. So what we will do here, we will keep sine square x, cos square x, and we are basically keeping one sine x outside. Now what we can do here is, if we take t as cos x, dt becomes minus sine x dx, which means that I can now convert this entire thing in terms of t. So your integral becomes sine square x is 1 minus cos square x. So 1 minus t square into t square. And here you have sine x dx, which becomes dt with a minus sign. So you'll have a minus sign outside. Minus of integral t square minus t to the power 4 dt. So just integrate, you will have t cube upon 3. And from here you will have t to the power 5 upon 5 plus c. You have a minus outside. So just take it inside. And this is what you will get as an answer. This is what you will get as an answer. Once you get up till here, you can just, so this would be plus, minus would become plus. So this is what you should be getting. Once you get the final expression, you can just convert t into cos x. Similarly, some other trigonometric cases. If you have to integrate sine x upon sine x plus a, what should be done? Just substitute x plus a taken as some t. So dx equals to dt. It becomes the expression would be now sine t minus a upon sine t. Now you can open up sine t minus a, sine a minus b is sine a cos b minus cos a sine b. So what you can do is just open this up, and hence what you will have is this expression. Now if you split it up, sine t cancels here. Or so you'll have cos a. Now a is just a constant. So cos a is just a constant. So it's not a variable. So t is not there. 1 dt because sine t cancels. Now sine a this time is just a value, fixed value, integral of cos t upon sine t dt. Now how can you integrate this? You can take sine t as u, so cos t dt equals to du, and hence you have 1 upon u du, right? Now when you will integrate it thoroughly, what you have basically here, you have t times cos a minus sine a log modulus of u plus c. Now substitute what is u, it is sine t, so you can substitute here. Now you have everything in t. Now t was x plus a, so please substitute that here. So you have x plus a cos a minus sine a times log mod sine t minus c times sine a, because sine a is getting multiplied by this, because sine a was multiplied by the entire integral. So constant is also a part of it. So you can just, keep on opening it up to the level that you can. So what I've done here is I've taken cos x cos a plus a cos a minus sine a times log sine x plus a is here. Plus c sine a. C sine a could be written as, it's just a constant, so you can just write it as a constant. Next question. 1 upon 1 plus tan x dx. 1 upon 1 plus tan x dx. What you can do is you can convert this to cos and sine. So tan x could be written as sine x upon cos x, and then take the LCM. Once you've done that, what you can now do, it depends what you want to use. You see, there could be different ways of using trigonometric identities. What I've done here is I've multiplied and divided by 2. So I have 2 cos x in the numerator, cos x plus sine x in the denominator. Now, what I've done next is I've added and subtracted sine x. So you will have an expression cos x plus sine x minus sine x plus cos x. So you have 2 cos x. So just split cos x with plus and minus sine x. So I've added and subtracted sine x. Add and subtract sine x. Add and subtract sine x. So half integral dx plus half of integral cos x minus sine x upon cos x plus sine x dx. Cos x plus sine x could be taken as t here, and then minus sine x plus cos x dx is dt. So you basically just have integral. This turns into just the integral. This turns into just integral of. So half is outside. This is dt upon t. So clearly what you can say, you have half of log cos x plus sine x plus some constant, and half of x plus some constant is there. So you can combine the constant terms, keep it outside, and keep the x terms one side. So what we have been working on was actually I've used some trigonometry. We've solved some trigonometric questions for integrating. Now, I want to discuss certain cases where you use trigonometric identities to solve any particular question. So suppose you have to integrate cos square x dx. Now cos 2x, recall cos 2x is 2 times cos square x minus 1. So cos square x is cos 2x plus 1 upon 2. Okay. So cos square x, integral cos square x becomes cos 2x plus 1 upon whole thing upon 2 dx. Now integrating this would be very simple because cos could be just, directly integrated as sine. That's why, instead of the power, we just wanted cos or sine in picture. So sine 2x upon 2, half I've kept outside, plus, 1, integrating 1 gives you just x plus the constant. So it will simply be 1 by 4 sine 2x plus x by 2 plus c. Next is sine 2x cos 3x dx. Now recall sine x cos y is equal to half of sine x plus y plus sine x minus y. Okay. Or in other words, if you open up sine x plus y plus sine x minus y, you will get twice of sine x cos y. So getting sine x cos y from here, and your x this time is 2x and y is 3x. So just put it up here. You will get that we will be integrating sine 5x plus sine minus x. We will be integrating sine 5x. So it's basically like integrating sine 2x cos 3x is same as integrating half of sine 5x minus sine x dx. Very simple to integrate sine 5x. It turns into minus cos 5x upon 5. And sine x becomes minus cos x. So minus minus gives you plus. So finally you'll get half. Half is outside. Half of cos minus cos 5x upon 5 plus cos x plus c. Sine cube x. Now how to solve for sine cube x? So what you can do is keep one sine apart. So let's call it sine square x into sine x dx. Now convert sine square x as cos. So 1 minus cos square x into sine x dx. Now substitute. Take cos x as t. So sine minus sine x dx becomes dt. So hence your expression turns into minus of 1 minus t square dt. Or in other words, t square minus 1 dt. Very easy to integrate that. T cube upon 3 minus t plus c. This is what we will get. Then just substitute. It's cos cube x upon 3 minus cos x plus c. So it is just about, somehow getting rid of the power and simplifying in terms of cos and sine only. Now we were talking about some particular functions, right? I was talking about some particular functions in the previous, just few questions back. So the first case that I had taken up, let me take that up. 1 upon integral of 1 upon x square minus a square is 1 upon 2a log of modulus x minus a upon x plus a plus c. Now how do we get that? So if you take 1 upon x square minus a square, it could be written as 1 upon x minus a into x plus a, 1 upon x minus a into x plus a, right? Which is equal to 1 upon 2a into 2a upon x minus a into x plus a. What have I done? I've just multiplied and divided by 2a. Dividing and multiplying by 2a. Now 2a could be written as a plus a. 2a could be written as a plus a. So now add and subtract x. So we are adding and subtracting x to this 2a, and that will give me x plus a. That will give us x plus a minus x minus. And now if you open it up, what will happen? Just split it up. So 1 by 2a is outside. So x plus a cancels, and you're just left with x minus a in the denominator. X minus a cancels, and you are left out with x plus a in the denominator. Okay. So if that is the case, you just have to integrate this term. And what 1 upon x square minus a square integral 1 upon dx is equal to 1 upon 2a integral of 1 upon x minus a minus 1 upon x plus a. So this gives you log x minus a, and this gives you log x plus a. And that's what we said will be the answer. This is how you get it. And if you combine the two, this is what it will look like. The next one, dx upon a square minus x square. Now this time we are doing a square minus x square, but we will proceed just like the same way. So what we can do is 1 upon a square minus x square, 1 upon a square minus x square, just multiply and divide by 2a. So 2a, or in the numerator also 2a, which is basically, you can write it as a plus a. You add and subtract x, so that now you can simplify. So you have a plus x, you have a minus x. Now when you split it up, you will have a plus x cancels. You have 1 upon a minus x plus 1 upon a plus x. You will have log. When you will integrate, now you integrate it. Integrating, what will you get? So it turns into like integrating this expression. So you are just integrating this expression. Integrate 1 upon 2a is outside. Integrate 1 upon a minus x dx plus integrate 1 upon a plus x dx. So this becomes 1 upon 2a log a minus x plus log a plus x. Whole thing plus c. Now this is minus since you have a minus x, so you have minus with x, so you'll have a minus sign here. So this will become 1 upon 2a, and this time in the denominator you will have, so it's going to be log a plus x upon a minus x plus c. So this is what